This is the end of Chapter 2 project tutorial. What we're going to be doing is utilizing StatCrunch and accessing the Parks Elevation data set. For Part A, we're going to use the Parks Elevation data set to draw both a dot plot and a box plot. And we're using StatCrunch to make these drawings. So in my Stat Lab, you'll notice on the left side menu, StatCrunch is available. So we'll click StatCrunch. We'll use the data sets from the textbook. We're in Chapter 2, so go to Chapter 2. And here you can see the list of available data sets. Our data set is called Parks, so we need to scroll down to find Parks. Click the data set. And here are the parks. We have 3 different columns of data collected for these parks. And these are actually Major League ballparks. So we've got the city, we have the slug percentage, and finally the last column is elevation. So elevation is the column we will be using for this project. For Part A, the first thing we're going to be doing is constructing a dot plot. So I go to Graph, find Dot Plot, make sure to choose the elevation column. The next thing we're looking for, and it's optional to change the point size. You can use the default of 2, or if you want a little larger size dot, maybe size 5, I'll choose that. The next thing I want to do is make sure to include the x-axis title, the y-axis title, and then a title for the dot plot. So for the x-axis, that would be the elevation in feet. The y-axis will be the frequency. Therefore, the title must be Frequency of Ballpark Elevations in Feet. The last thing we'll need to do in the lower right-hand corner is to click Compute. And here you can see is the graph. This is our dot plot. You can see that the title is given already. You've got each axis titled as well. So it looks like most of our dots are clustering at the left side, and then we have one ballpark very far away to the right. The next graph is the box plot. Again, we're choosing the elevation column. And looking at all of our options here, we do want to have the option of the fences being drawn to identify any outliers. And I have a preference for horizontal box plot, so I'm choosing to click that box as well. You can label your axes again right here. So the x-axis is elevation in feet. My y-axis is frequency. And the title is Frequency by Elevation. Now, with the box plot, I would prefer also to have some vertical lines drawn so that it will make it easier for me to see the actual values of my 5-number summary. So I'm choosing vertical lines. The last thing to do is to click Compute in the lower right-hand corner. Now look how this is all squared off. I would prefer to have my box plot a little narrower, so all you have to do to adjust the size or the look of the graph is to move your cursor to one of the sides until it changes to an arrow, and then you can shorten that or make it taller any way you'd like, or go to the corner, and that adjusts both the height and the width at the same time. So you'll just have to play with that. It's your own personal preference on how you want to adjust your graph. Notice though, the vertical lines are very pale. Once you copy paste this to Word, you'll be able to see those vertical lines a little better. So we can see our whiskers on both sides. You see your median of the data, the lower and upper quartile, and notice very far to the right you've got that outlier again. If you place your cursor right on the box plot, then a box of your 5-number summary will appear, which is useful. So there we have everything we need for Part A of the project, and you can simply copy-paste these into a Word document. For Part B, I'm going to show you how to use StatCrunch to collect the stats on these elevations. So we'll click Stat, Summary Stat, Column, and the column we want is Elevation. Now we do want to find the mean, so I first click just one option, Mean. Then I'm going to hold down the Control key and include Variance, and see how that was added to the drop-down. And then we want Standard Deviation. Bring this bar down a little bit to get Median and Range. So we have Mean, Variance, Standard Deviation, Median, and Range. Those are all of the stats we're looking for. So we can press Compute. Now notice the box has all of the headings, all of the values. It would be fine to round off these values to the nearest whole number for your project. So instead of recreating this whole table by hand, you can simply copy and paste it to your Word document. So I'm going to highlight all of the values that are in the table and its title with my mouse and press Control-C to copy it, click on my Word document, Control-V to paste it. And there we have the document. And if you don't want your table in this particular location, you can click on this small box and move it somewhere else. You can also take the title and drag it lower or wherever you want to place it. Okay, so there are some tips to help you not have to recreate tables. You can simply copy and paste them. In Part C, you're going to use Chebyshev's rule and the empirical rule to describe the distribution of the data set. Now remember, this is the whole population. Our population are these 29 elevations. So we're going to count how many of those elevations actually fall within 1, 2, and 3 standard deviations of the mean. So in order to do this, you might find it helpful to sort the data from the smallest to the largest values. And you can do this by clicking on the Data tab, and Sort is almost near the end. We want the elevation column, and we do want ascending order, and that's already the default. Compute, and you can see that a new column has been made. So from 10 to 5277. Now 10 does not go with Anaheim. Just keep that in mind. All that this column is telling us is the lowest to the highest elevation. But that will help you go ahead and maybe even double check your dot plot to make sure you haven't forgotten any values. But it will make counting a lot easier for you to determine how many of these measurements fall within 1, 2, and 3 standard deviations of the mean. So I'm going to move this table just out of the way a little bit. And if I have a standard deviation of 972.6, I'm calling that 973. So 973 is going to be added to the mean of 559. And that tells me what the numerical value would be 1 standard deviation to the right of the mean. If I start with 559 and subtract 973, that tells me what the x value is, or the elevation, 1 standard deviation to the left of the mean. Now notice that's going to be a negative number, and we're not going to have any negative elevations if you look down this list. All right, we have nothing that's below sea level. So we won't need to go beyond 1 standard deviation to the left of the mean, because those negative numbers don't make any sense for our data set. Once you have the count, that is how many of these elevations fall between the mean and the first standard deviation, you're going to count how many, but don't forget to divide by 29, because there are 29 total elevations. That will give you a decimal, multiply by 100, and you will then have what percent of your data falls within 1 standard deviation of the mean. And you do something similar, count how many fall within 2 standard deviations, divide by 29, multiply by 100, and you will have your percentage. Then you can compare your percentage with Chebyshev's and the empirical rule. In part D, we're going to be using StatCrunch to generate a random sample from our data set. So we're going to follow these bullets and create a sample. So the first thing we need to do, we already have StatCrunch open, we've got the ballparks, so we go to the Data tab. And now we're going to look at Sample, about halfway down. We want the elevation. We want 10 for the sample size. So we're all going to generate a random sample of just 10 of these ballparks, or 10 elevations. We only need one sample. Everything else is set to a default. Leave those. Compute. Now I'll move this column out of the way. I have to reveal the ballparks. Here they are. So you can see we have 10 randomly chosen elevations. With this new set of data, notice it's called sample elevation. We can move this bar over, and now you can see the whole heading, sample elevation. So with these 10 elevations, we are now going to recalculate the mean, variance, standard deviation, median, and range. So I'm going to go to Stat, Summary Stat, Columns, but this time we don't want elevation, we want our sample elevation. So make sure you're choosing the correct column, sample elevation. And we'll first click Mean, then hold Control, choose Variance, Standard Deviation, drag the bar down so you find Median, drag down some more until you find, where is it, Range, there we go, and Compute. So now we have another table of information, but it is called sample elevation, so you can keep track of all of these different tables that we've generated. And you can generate them all like I've done just now, and then copy paste them to your Word document, or you can copy and paste them as you're writing your report. It's up to you. So in order to copy this to my report, remember I'm just going to select it by dragging my mouse and highlighting all that information, Control C, find my Word document. So make sure that you are putting your mouse away from the other columns so that they don't mesh together, Control V, and there it is pasted, Summary Stats. But you'll be able to keep track which is which because you do have the titles also included here for which column of data this is. So you should be able to keep track of that. Now for part F, you're going to be using this sample elevation data to help you make your count. You're only using these 10 elevations now, and you're going to redo your count using the new mean and standard deviation just for your random sample. So I'm starting with a mean, and I'll round these to the nearest whole number, 544, and then I would add 380 to know what the first measurement value or first elevation value for one standard deviation to the right of the mean. Then I would take the mean and subtract the standard deviation to find out what the measurement is or the elevation for one standard deviation to the left of the mean. Now 544 minus 380, that's still going to be a positive number. So I will be able to continue to 2 standard deviations to the left. Make sure that once you get your count, you're dividing by 10 this time because you only have 10 in your sample. And then convert that decimal to a percentage by multiplying by 100. You can then compare your percentages with Chebyshev's and the empirical rules percentages. And that's what you're going to be doing to finish up part F. The final part of the project is Part G, and Part G is a discussion. So by discussion, I mean just a few sentences to talk about the difference between the symbols that you're using that represent sample mean versus population mean. So there are different Greek symbols or other symbols that are used to separate sample from population. Do include what the symbols are and what they represent. So this should be just a few sentences in length. Once you complete your Chapter 2 project, you'll need to open Blackboard. In Blackboard, you're going to scroll down to Chapter 2. Open Chapter 2. At the bottom of this folder, you will find the project submission. So it's the last item in this Chapter 2 folder called Submit Chapter 2 Project. Open. And in this folder, you're going to find a reminder that you are submitting your project in PDF format. That is the only format that will be accepted. So make sure that you are able to scan your project, save it as a PDF, and submit that PDF file. So you'll need to browse your computer to find where you saved your project. Feel free to write any comments or questions here in the text box and then click Submit. I hope you find this tutorial helpful with your Chapter 2 project.